All right, part one, we want to talk about basically what happens when nothing happens. So it's Newton's first law. Again, we've talked about this before. When an object moves in a straight line at a constant speed, or it doesn't move at all. I mean, as long as it's not changing its speed and not changing its direction. If it's not moving, it's not changing its speed and it's not changing its direction because it's just sitting there. Then the forces balance on the object. And we have to remember that these are all forces coming into the object. What does that mean? Well, this is a little bit more complicated. So we want this v vector to be constant. Going in a straight line at a constant speed. So that means that speed does not change. And direction does not change. Both of those stay the same. That was rectilinear motion. Means, or implies, that little arrow means implies, the sum of all of the forces, the vector sum of all of the forces, is equal to the vector 0. Okay, so let's look at that first part. We'll just stick with that first part. What does that mean? Well, that means that this object will move along this path with the same speed. It's not going to turn. Every 3 seconds it ends up the same distance away as before. That's it. So the object will just move along like that. That means that this thing here is also a vector sum. So remember, vectors have something to do with positions and motion in some way, and so do the forces. The forces are going to be later on proportional to acceleration. Forces are vectors. You did a little lab on that. And they add vectorially, which means that if you have a vector here, 1, and a vector here, 2, and a vector here, 3, and a vector here, 4, then you have a final vector, and it's not letting me have colors. Oh, there it is. Here, which is the sum of all of the forces. F1 plus F2 plus F3 plus F4. So conceptually, we're just laying these vectors end to end. Computationally, we just add up all of the components. So we add the x component of 1 to the x component of 2 plus the x component of 3 plus the x component of 4. Then we do the same thing for the y components, the y component of 1 plus the y component of 2 plus the y component of 3 plus the y component of 4. And those give us the x and the y component of this sum, which we call the net force. And these individual forces are the applied forces. Okay, so that's the sum. For this, you don't get something like this. Instead, you get the sum adding up to 0, which basically means that 1 and 2 and 3 and 4, when added up, take you back to the same place. Okay, so just like this. So this is a balanced situation, this is an unbalanced situation. This is when Newton's first law is in effect. That is, this is when, well, I shouldn't say static, but this is when you're going to continue in a straight line at a constant speed. When the forces are zero, when they balance out. And so you remember when your lab you had a little ring and some strings with masses coming out. And so these all had to add up. For everything to be balanced, these all had to add up to be zero. The force, if this is 1, 2, and 3, it's 1 plus 2 plus 3. All right? So that's basically what statics does for us. Next we'll go on for an example, quick example. Then we'll talk a little bit about weight, and then we'll talk a little bit about some other forces, reaction forces that you may run into. Bye now.